This is Charumati from RI Mysore, and I'll be talking about cluster beam evaporation. So, when you're talking about material physics, in particular, when you're dealing with nanoparticles, you have to synthesize them, right? So, you would have definitely come across something called the nanofabrication. So, it is basically referred to the process of making nanoscale materials and devices. So, when you're dealing with nanofabrication, in particular, we'll be talking about cluster beam evaporation here in our video. So when you're talking about nanofabrication, would have definitely come across these two terms, right? Top-down approach and bottom-up approach. So what does this top-down approach means? It's just breaking down of pieces of material to generate nanostructures from the bulk material. Whereas when you're talking about the bottom-up approach, it implies of combining single atoms into larger nanostructures, which can be explained with this particular image. So when you have atoms, ions, and molecules under certain heat conditions or pressure conditions, and upon certain chemical reactions, you can convert them to nanoparticles. So this is nothing but your bottom-up approach, like you're going from the bottom to the out, like you're going from the smaller one to the bigger one. So this is your bottom-up approach. So when you're talking about the top-down approach, you have the bulk precursor, which is crushed down using various mechanical methods into nanoparticles. That is the particles to a desired size. So this is a bottom-up approach and your top-down approach. So in particular, since you're talking about this cluster beam evaporation method, which one do you think, in which category do you think it will fall into? It's nothing but your bottom-up approach. So how is this being carried out? So is what we are going to talk today. So now we'll be talking about the vapor deposition method. So this is the most widely used bottom-up approach in nanofabrication, like when you're dealing with nanotechnology and research. So basically there are two types of vapor deposition techniques, okay? The physical vapor deposition technique and the chemical vapor deposition, also known as PVD and the CVD methods. So generally speaking, like here when you're talking about this vapor deposition method, you have something called the substrate, which acts like the foundation, and we'll be depositing any material or film onto the base of this substrate. So it's all together is known as film. So this substrate is the foundation, and we'll be depositing thin layers of our desired material on top of it, and all together is called a film. So how thin this would be, right, when you're talking about in nano terms. So how is that process of how thin, how is it, like how thin is this film ground? So this process can be explained like with a small diagram. So the first process, the physical vapor deposition method. So first we will talk about the physical vapor deposition method. Slowly we moved on to the CVD or the chemical vapor deposition method. And since our cluster beam evaporation topic comes under physical vapor deposition method, in detail we will discuss about physical vapor deposition method. So here the whole process is basically performed in a chamber, a space often which is vacuum. So this whole space is said to be vacuum. The substrate is placed in a reactor chamber under this vacuum. The source gases are basically, see here we have this argon gas which is like pumped into this reactor, which will react with the sputtering target. Like this is what is the, out of this particular thing is what you are going to, you want the nano material to be like. This is what the material in which you want the whatever nano device or nano stuff which you are preparing should be made of this material. So here you will have that, and here you have the substrate. So this is basically, I told you, it's the foundation. So when the source gases are pumped to it, that is into this particular reactor, which will react with the surface of the substrate. So this substrate will get exposed to the vaporized sources. So when you're pumping onto this gas, the substrate gets ready for accommodating these sputtered target atoms from the target material. So how do you cause the sputtering of these materials? So the sputtering of these materials is usually done by using this external stimuli, such that some heat or plasma or something that would initiate or propagate the reaction. So when this substrate is exposed, this particular substrate is exposed to these sputtered target atoms, these sputtered target atoms will deposit on the substrate. So this happens like a thin film that will start depositing naturally on the surface. So this thin film will react to the required level, like how based on the gases how which you are providing it. So in this physical vapor deposition method, the source is basically a solid. That is, the source is in a solid form. So which is basically converted into a vapor, and then it is coated on the surface of the substrate. Coming back to our topic, we'll be talking about our cluster beam evaporation. So here it's basically a bottom up approach, and it's also a physical vapor deposition method. So we are going to prepare nanostructured materials using the method of cluster beam evaporation. So it's a bottom down approach. So it involves like atom by atom or by molecule or by cluster, whatever we desire. So aggregates will ranging from just few atoms or molecules, like it will go thousands or lakhs in numbers, are held together by some binding forces or some binding energy, which is a few tenth of electron volts or some several electron volts, and these are known as clusters. So this is the cluster source. This is nanoparticles basically source. So this is in the form of a cluster. So the construction and working of this particular experimental setup is you have the nanoparticle source. This part of the apparatus is known as the expansion chamber, and this part is known as the deposition chamber. You also have vacuum pumps. You also have the substrate here. So how does this work? So first of all, let's talk about the source of the cluster. The cluster source contains aggregates in gaseous phase. The clusters are formed like from here either by physical means such as by conduction of supersaturated vapors or by some chemical reactions that would convert it into the desired form. So next we have the expansion chamber. In the expansion chamber, we have this vacuum, and the cluster beam from this cluster source undergoes supersonic expansion to the small opening here. Okay, this will provide a small opening to the next part, that is to the deposition chamber over here. So in the expansion chamber, which is vacuum, the cluster beam from the cluster source undergoes supersonic expansion through the small opening or the orifice provided in the expansion chamber. So the next we are going to talk about the deposition chamber, that is the third part. The central part of the cluster beam enter the second vacuum chamber, that is to this part, which is the deposition chamber, through the small skimmer, which is used to like geometrically confine. Here we had a small orifice to like expand the cluster beam. Here we will have something called a skimmer which will confine the nanoparticles which are coming from the cluster source to get deposited on the desired substrate. So these, you might ask me, why are these vacuum pumps present here? These are basically to provide, to create vacuum in the expansion chamber and the deposition chamber so as to create some low pressure. So why is low pressure required? It is to increase the mean free path, which will enhance the deposition process and also to avoid undesirable impurities, and hence will decrease the contamination. So this is the major role of the vacuum pumps which are present in this particular apparatus setup. So the next one we'll be talking about is the advantages of this method. So what are the advantages of this method? So when you're talking about the advantages, there is less surface damage for the substrate because the vapors will just get deposited on it. The substrate has nothing to do, like I mean, they just absorb whatever is coming and there is no much damage to the surface of the substrate. Then it will give you the high degree of purity, like there's a less chance of impurities. Then it will give you exact particle size control, and you have high stability and high repeatability, and there is high lateral resolution, and there is parallel focusing when you're dealing with cluster beam deposition method. So when you're talking about the disadvantages of this method, it is limited to low melting point materials. Like if the material melting point of the precursor material, that is the cluster source material, is like too high, then it is very difficult to convert it into vapor form. We are basically converting the solid into vapor here. So if the melting point is too high, then it is really difficult for it to convert it into vapor form. So materials which have a very low melting point, it is very difficult to convert it into vapor form. Now you have poor density and adhesion. What do I mean by poor density and adhesion? So as the vapors from the deposition chamber will start coming, they get deposited directly. When it reaches the deposition chamber, it will start getting deposited on the substrate like this, right? So when it starts depositing, the surface properties of the substrate which you are using will basically decide the bonding of the material which is there on the whatever vapor is coming. The surface properties of the substrate will also determine the property of the material which you are preparing. So it can lead to poor density and addition. So one more very important thing is it is not possible to evaporate dielectric materials. So this method is not useful when you are talking about dielectric materials. Now let's we definitely have to know the applications of it, right? Why studying this is more important. So in order to know that, when you're talking about the applications of cluster beam deposition, we first talk about the automotive and aerospace industries. So especially they use this electron beam evaporation when they are constructing components that should have very high wear resistance. So optical thin films is the next application. So multi-layer electron beam evaporation allows for the production of very thin films which have unique reflective and transmissive properties. Like we say that as the surface area increases, then the properties would naturally would change. So we have the metallic films. With the electron beam evaporation of these low resistance metals, manufacturers can produce various films including wiring films, decorative films, and electromagnetic shielding films and reflective films. So these are some of the applications of the cluster beam deposition method. That's all for today. Thank you.